Welcome back to the Firebase I/O video series. I'm James. I'm a developer relations engineer for Dart and Flutter. In this video, we'll discuss some of the design decisions that help Flutter thrive on the mobile platforms it targets. When people talk about cross-platform frameworks, there's often an underlying assumption. There's this idea that if you aren't writing pure Swift or pure Kotlin, you're settling for the lowest common denominator experience. That you can build simple cookie-cutter apps, but the moment you need to dive deep into native integration or high-performance UI, you've hit a wall. But the data tells a very different story. Today, Flutter is the second most popular app development SDK in both the App Store and Google Play. With over 1.5 million monthly active users and a platform powering over 1 million apps, we aren't just building simple apps. We're building complex, high-performance software compiled to native machine code. Our customers are using Flutter to provide food delivery for a whole region, to help people understand what's going on in their vehicles, and to unwind at the end of a day. Today, I don't want to talk to you about how Flutter replaces native development. I want to talk about how Flutter integrates with and enhances it. There's a lot of specific and intentional effort that goes into making something that doesn't just work on multiple platforms, but thrives on them, mixing inspiration, gestures, and cues from the host OS while also holding space for personalization and innovation. Before I worked on the Flutter team, I worked on design with Material. My first assignment was helping internal developers move from Material 2 to Material 3. From that vantage point, I was able to see all the little ways apps would break when moving to a new version of the design system. Subclass a material widget and fail to account for one of the dozens of material colors in your theming. Suddenly you had a random case of purple precipitation. These types of challenges that occurred when moving between major UI theme versions or when implementing a new design system caused the Flutter team, to really look at what it would take to decouple the design libraries from the framework. Large-scale migrations, like from Material 2 to Material 3, and the Cupertino refresh exposed technical debt that was making our efforts more difficult. Clearing those log jams was the first step, because before we could begin to do the core work to make it easy to implement any design system, we had to decouple Material and Cupertino from the framework and themselves. Duplication of properties and logic were moved to base classes. Core widgets containing logic but no styling were created instead. We worked to make Material and Cupertino as lean and non-duplicative as possible. The next phase, where we currently are at the time of this video, has the key steps of freezing the current implementations of Material and Cupertino that come inside the framework and making first-party pub packages, Material_UI and Cupertino_UI respectively, where future development will continue. The completion of this multi-year effort means your app's UIs won't randomly break because you updated to the latest version of Flutter. It makes it easier for us to plan and collaborate with our community on the recent UI updates from Google, like Material 3 Expressive, and Apple, Liquid Glass. Making a new design system will not have to start with subclassing an existing UI framework and patching all the unintended artifacts. We've also done work enhancing how Flutter can make use of shaders and low-level graphics pipelines, like Metal and Vulkan, which will make imaginative designs and concepts more feasible. You can follow our progress on GitHub or see our design and rationale at flutter.dev/go/decouple design. That last bit flows into one of our more complex technical challenges in cross-platform development, embedding native views inside a Flutter app, specifically Android views. When running on Android, Flutter paints its entire UI to a single texture and bypasses the traditional Android view hierarchy. So where and how to fit a native Android view in is a challenge. To facilitate this need, over the years we devised multiple rendering techniques, each seeking to solve the existing problems of the then current method or make use of new hardware capabilities. First, we created the virtual display mode. This rendered the native view into an off-screen buffer, which was then piped into a Flutter texture. While it integrated well into Flutter's drawing system, it was fragile and frequently broke text input and accessibility. Next came hybrid composition. To fix the fidelity issues, we placed the native view directly into the Android view hierarchy. This offered improved compatibility, but tanked Flutter's performance, forcing an expensive GPU to CPU round trip for every frame on older Android devices. Texture layer hybrid composition came next and combined the best aspects of virtual display and hybrid composition by redirecting native drawing into a texture. It restored Flutter's baseline performance, but it broke if the native component relied on a surface view. Designed to be the unified solution, Hybrid Composition ++ is currently available as an opt-in feature for devices running Android API 34 or later that support Vulkan rendering. Instead of relying on off-screen buffers like virtual display mode or forcing the Flutter engine to do the heavy lifting, Hybrid Composition ++ leverages OS-level Android APIs to natively composite the layers. Android hardware buffer swap chain and surface control transactions drive the work to synchronize the Flutter UI with native views. This finally enables surface view support, high-performance scrolling without screen tearing, and high-fidelity touch input, all without the severe performance penalties of the previous implementations and methods. This will be the default rendering mode in the future, so we encourage you to try it out. You can test it now by adding a flag to your Android manifest or your run command. On iOS, we're also tackling developer friction. For years, dependency management in the Apple ecosystem has been a headache, specifically the heavy reliance on Ruby and CocoaPods. We're changing that by making Swift Package Manager the default in Flutter 3.44. This provides two big advantages. First, ecosystem access. Flutter plugins can now directly participate in the growing ecosystem of Swift packages. Second, simplified installation. Since Xcode includes Swift Package Manager natively, you no longer need to install Ruby or manage CocoaPod environments just to get your project running. It makes the Flutter environment cleaner and more aligned with modern Apple standards. To use Swift Package Manager on existing projects targeting iOS or macOS, your project will need to be running at least Flutter 3.24, and all plugins must have migrated to Swift Package Manager. Otherwise, your app will continue to use CocoaPods. But what about when you need to go even deeper? For example, accessing low-level native APIs directly. This is where our native interop solutions, specifically NIGen and FFIGen, come in. Currently, these are experimental, but development is brisk. These tools allow you to generate Dart binding code to interact with native code directly. We've covered them in more detail in previous I/O talks, so see the description for links to the videos and relevant packages. For iOS specifically, our interop currently relies on a bridge using Objective-C, but more and more libraries are offered as Swift only. While it's possible to finagle calling them via Objective-C and thus from Dart, we're working on SwiftGen to generate Dart bindings directly from Swift, further reducing that friction. Whether it's through the precision of Hybrid Composition ++ on the latest Android devices, the seamless integration of Swift Package Manager on iOS, or binding directly to native code, our goal remains the same. It's about providing a high-fidelity, high-performance framework that respects and enhances the native platforms it runs on. Flutter allows you to bring your app's vision to a wide array of devices beyond just the expected mobile and desktop onto cars, TVs, and embedded. We're giving you the tools to build apps that aren't just cross-platform, they're world-class. Thank you. If you're not done learning for the day, check out some of the other videos in this Firebase I/O series.